Sí, adelante, por favor.
Bueno, pues muy buenos días a todos. Bienvenidos
Recording
al
in progress.
seminario. Perdón. Bueno, muy buenos días a todos. Decía yo que bienvenidos al seminario institucional de nuestro instituto, el Instituto de Ciencias de la Atmósfera y Cambio Climático. El día de hoy tenemos la presentación por parte del grupo de contaminación ambiental, que tiene un invitado. En estos momentos lo va a presentar el doctor Sosa, pero antes les recuerdo que nuestro seminario es todos los viernes o un viernes cada 15 días a las 12 del día. Entonces, pues bienvenidos todos, bienvenido el doctor David Guy, y adelante, por favor, doctor Sosa.
Gracias, doctor Zavala. Es un honor para mí tener como invitado el día de hoy al doctor David Guy. Hago alguna semblanza breve de él. Él es científico ambiental, estamos hablando desde los años 80 en la empresa Hill CHD en Portland, Oregón, en el cual tuvo a cargo la estimación de emisiones, monitoreo de meteorología y calidad del aire, enfocado a contaminantes criterios, manejo de residuos, contaminantes tóxicos, propuestas e informes y logística en todas las operaciones en el aspecto ambiental. También una labor muy importante de vinculación entre el gobierno en la industria. Estamos hablando de finales de los años 80. A su vez, ha sido académico de la Universidad de Carolina del Norte en Charlotte, trabajando bastante en la parte de ciencias atmosféricas, y ha sido estamos hablando desde 2003, participante en el National Atmospheric Deposition Program, teniendo ya bajo su responsabilidad este programa muy importante para los Estados Unidos desde el año 2008. Actualmente, como coordinador del National Atmospheric Deposition Program, tienen bajo su mandato las redes de química de la lluvia, que es la National Trade Networks, la red de mercurio, tanto en depósito como en aire ambiente, la red de amoníaco y también recientemente la red de aeroalergénicos. También en su background como profesionista y su formación académica, él estudió su doctorado en la Universidad de Virginia, lo llevó a cabo en ciencias ambientales, su maestría la realizó en ciencias atmosféricas en la Universidad de Washington, y también la parte de su licenciatura en ciencias ambientales en la Universidad en Lake Charles. A lo largo de este tiempo ha elaborado también en colaboración en proyectos internacionales, destacando tanto Asia, Europa y Latinoamérica. De ahí el contacto que tenemos con el doctor David Guy desde hace muchísimos años. En este momento, él va a hablar de una alícuota de lo que es NADP, y es precisamente lo que se refiere a la red de mercurio y la importancia que tiene este contaminante a nivel global. No le quito ni un minuto más. David, thank you very much to accept to participate in this seminar. Welcome again to Mexico.
Thank
Please
you,
go
Dr.
ahead.
Sosa.
Please go ahead with your presentation.
I will.
Nice to have your
Yes.
again. Okay. Thank you very much, David. Go ahead.
No, it's an honor to be here, and thank you, Rodolfo, for inviting me, and Dr. Zavala. Again, as I said, it's an honor to speak here today. Rodolfo and I quickly went through some ideas, and basically I'm going to give you a quick talk about the general topic of mercury. My official title, the National Atmospheric Deposition Program, Mercury Measurements in the U.S. and New Directions. We're going to go with Mexico. The talk is really in three parts. I'm going to basically talk about the general mercury problem, what it is and why it has come to be. some basics about what we know about mercury in the US. And then third, I'll talk a little bit at the end about some new directions we're proposing to go with Mexico. And so with that, and if there are any questions, I'm happy to answer those at the end. So with that, there we go. Almost having a little problem advancing. So the very basic question I usually start with is, why is it important to worry or measure mercury in the environment whatsoever? As most of you are, I'm sure, well aware, mercury is an element. And why is it an issue? And so that's the first third of my talk. And I always start with this simple idea, and that is the mercury problem in the environment is really not elemental mercury that we're all familiar with, that we studied in chemistry, that we saw in our chemistry classes. The mercury problem really boils down to the organic form of mercury, which is actually several compounds, but is classically talked about and brought together as methyl mercury. So that's where the mercury problem starts, with the organic form of mercury. All mercury compounds are toxic to a certain degree, but the really important one, this methyl mercury compound, is it's basically a human health concern. It primarily is it's referred to as a persistent bioaccumulative neurotoxin. And so what it causes, the problems it causes, is neurological disorders, principally in children. These same neurological disorders can happen in adults, but it's primarily with children. As children are growing, their brains are forming. If there's quite a large concentration of mercury in the body, it can create lots of problems. It can also lead to birth defects and learning disabilities. Primarily, the children that we're really interested in are the very young ones. Somewhere between the age of 7 and 12 years, most people develop defenses against mercury poisoning. So it's really the young kids that we're interested in, or that we're more worried about. And we worry quite a bit about pregnant women, because if they are pregnant at the time and have mercury in their bodies, that mercury is also being delivered to the fetus. And so it's the primary issue with mercury, or the focus is with pregnant women and children under, we'll say, 12. There are other disorders that are possibly linked to mercury, and that'd be kidney disorders. It's a possible human carcinogen, and it is at least linked to heart disease. I'm a physical scientist. I know nothing about the biological end of things, and so I'm not 100% sure where the research is on that. But again, the focus from a health concern is on children and fetuses, or therefore pregnant women, who could pass it on to their children. About 15 years ago, they did some wide-ranging surveys across the United States, and the estimate was about 5.6% of women in the US had blood levels of mercury in excess of 5.8 micrograms per liter, considered to be an action rate by health officials here in the US. So it's a very subset of people. It tends to be children and women that eat a lot of fish, and I'll get to why that is in just a second. And so it's also particularly important in coastal populations, and we'll talk more about that in just a second too. So I said a little bit ago that the problem is methyl mercury, not necessarily elemental mercury. And it's a question of biomagnification of this methyl mercury concentrations. You can have very low concentrations in the environment, but that concentration is picked up by very small protozoa and small animals. Those concentrations get eaten by the small fish, concentrating more mercury in their bodies. The small fish get eaten by the middle-sized fish. The concentration again goes up. The medium-sized fish get eaten by the bigger fish. the concentration exceeds there, the big fish are eaten by the carnivores, and the concentration can go up, increasing anywhere from, we're talking picograms per liter of water in some cases, up to parts per million in certain fish populations. And that's the concentration level that humans are exposed to. Mercury cycle basically works simply like this. Most mercury is coming in through the atmosphere. It's being deposited to a water body through rain washing the atmosphere out of mercury, or by the mercury in the atmosphere being dry deposited to the tops of these water bodies. Mercury then moves down into the water, down into the anoxic regions of the body, or the water body. It's coming in primarily as mercury salts out of the atmosphere, mercury chloride, mercury bromide, mercury oxide, etc., deposited in the water body, moving into the anoxic parts of the lakes and rivers down at the bottom in the muck and sediments. At that point, several species and genera of geobacter primarily are actually converting mercury into the organic form as a way to defend against the poisonous impact of mercury on their bodies. That methyl mercury then moves out into the water, where it gets picked up by the very small organisms living in the water, and the whole biomagnification chain begins to exceed at that point, starting with picograms to nanograms down in the anoxic region, moving up to potentially parts per million in the fish. And then you have animals that are eating the fish out of those water bodies, and of course, people. The real action is happening in the wetlands, down in the bottom, in the water, in the anoxic waters. Sulfite present in these waters tends to increase the rate of the formation of methyl mercury. Where you have low light penetration, high DOC, so dark waters that we find primarily in the US and the southern regions, promotes high levels of methyl mercury. And so that's sort of the basic way that everything works to get the problem of high levels of methyl mercury in water bodies and in foodstuffs, fish, etc. And so from an atmospheric scientist standpoint, which is what I am, the question becomes, well, how did that mercury get to the water body itself? And then it becomes a question of emissions. Where is that mercury coming from? And that mercury goes up in the atmosphere, is transported downwind to water bodies. And then the removal process is both wet and dry deposition. I've used this slide for quite a long time to show people that, at least as far as we know, the methyl mercury and mercury problem in the environment is quite wide ranging. This is a graphic of fish worldwide that have been shown to have fairly high concentrations of methyl mercury in their system. And when I use the term fairly high, we're talking about 0.3 part per million or greater. And as you can see, everything with a yellow or red dot is a fish, a type of fish species that have been measured to have concentrations of methyl mercury over 0.3 part per million. And the point of this slide is, this is a global problem. It happens everywhere. Not all fish have high concentrations of mercury, but the fish that have high concentrations of mercury are across the entire globe. So we're talking marine fish, we're talking landlocked fish in lakes and rivers, we're talking about fish living at high elevations, at low elevations, northern hemisphere, southern hemisphere. We find fish with high concentration of mercury everywhere. Just a few examples of some of the fish species that tend to have high concentrations, and again, above 0.3 part per million. They tend to be the very large fish, tilefish, sharks, swordfish, orange ruffy marlin, The fish that are very large in size tend to be at the top of the food chain and therefore experiencing the overwhelming majority of biomagnification. I get a lot of questions when I talk about these sorts of things about tuna, because tuna is wide-ranging and consumed by lots of populations. I hate to say it, but the answer of the concentration of mercury in tuna is it depends. It depends where that tuna was caught, how big that tuna was, but tuna fish can be from very low concentration to very high concentration. It just depends on a lot of different factors. But fish that tend to be at the top of the food chain, the ones that fishermen try to catch, usually have very high concentrations. The fish that tend to be on the low end of the food spectrum, and that would be, like salmon. Salmon are basically grazers. They tend to have very low concentration. The filtering organisms, oysters, etc., tend to be very low. Lobster, very low. It just is a function in part on where they are eating on the food chain. So the bigger the fish, they tend to have higher concentrations of mercury. Another just quick example. This was a study done by the U.S. Geological Survey a few years ago. They went out into the west. You'll see the map of the western U.S. on the right, and did concentrations on all different kinds of fish species, all different sizes, and reported back those results in a normalized fashion. And again, I'm just showing this to show you that fish concentrations here in this map, represented in yellow, orange, and red, all have concentrations at or above 0.3 part per million. And this is just another example to show you that even fish that are near urban areas, so like this is San Francisco, and down here in LA, you see a lot of high concentrations, but even in South and North Dakota, you see quite a number of fish with very high concentrations of mercury that are very far from population centers and very far from any sources of mercury going into the atmosphere. So just because you don't have a mercury source near you does not mean that the concentrations of fish grown in that area are going to be low in mercury. It depends on a lot of different factors. Here's another very good example here in Canada, out in the middle of basically nowhere with very few people around and very few sources of mercury. There's very high concentrations of mercury in fish. And I always show this picture too, because mercury scientists like myself, we tend to focus on fish and fish concentrations, but it's not just fish. It's everything that's eating within a lake or a river that has fairly high concentrations of mercury. And in about 30 minutes one day, I found scientific papers suggesting that at least part of the population of all of these animals and insects had fairly high concentrations of mercury in some particular locations. So I always hit on the fact that it's not just fish, it's everything that's eating in these particular wetlands or lakes, rivers, what have you. So that's sort of a quick tour of the mercury issue. So we know it's a problem, and we know that it's not necessarily elemental mercury, but methyl mercury, the organic form of mercury, and it's a problem in biospherence fish. But what are the sources of this mercury? Which is another huge question. And I've used this slide for years too, and I know there's a lot of words on here, so I've highlighted a few of the more important sources of mercury, and I'll talk about those individually. But what I wanted to start with is saying that mercury is an element. It's been here since the beginning of time. There is lots of mercury in lots of different places. Basically, mercury is everywhere. It's in very low concentrations in most locations, but it's basically everywhere. The source of mercury to the atmosphere that most people focus on is coal combustion. Now, there have been a lot of restrictions go into place for mercury emissions from the combustion of coal with power generation in the US, in North America overall, quite honestly, and in Europe. But coal combustion still is a very large source of mercury, but it's primarily not the biggest source anymore, we don't think. This is the one that has come into play in the last 15 years or so, and that's artisanal or small scale gold mining. Gold forms an amalgam with mercury quite rapidly, and so they use mercury, elemental mercury, to collect gold when they're mining, and they tend to just evaporate the mercury away. And I don't know how much gold and silver mining is occurring down in Mexico, but I would imagine there are some regions where it's very important. And I know it's extremely important as a source in South America. Cement production is another one. Mercury is usually part of the raw materials that go into cement production. And the first thing they do is heat it. The mercury in the raw materials gets volatilized to the atmosphere. Here is a new one that we don't pay much attention to in the West, but over in Asia, vinyl chloride production uses mercury catalysts in a very old methodology they used to produce vinyl chlorides from the 50s with a mercury catalyst, and this is a huge source of mercury in Asia. Automobile recycling, a lot of older models of automobiles have mercury, and automobile recycling is a fancy word for crushing an automobile down and melting it. When you add the heat, all the mercury in the components goes up into the atmosphere. Any kind of incineration generates mercury emissions. I will point one out. Oh, this one. Something that no one ever thinks about, but cremation of bodies. Most people my age, and I'm approaching 60, have metal or mercury silver amalgams in their teeth when they got a cavity when they were a kid. If you cremate a body with a mercury amalgam filling in that person, all of that mercury goes to the atmosphere. And in the mercury emissions databases, you'll find all the crematoriums represented. In some states in the US, you have to remove teeth with mercury fillings in it before you can cremate the body. It's that of much of an important source. Sort of strange to talk about, but it is a source of mercury to the atmosphere. There is mercury in gas and crude oil. Not a whole lot in gas, and it depends on what oil basin the oil came out of, but a lot of the basins in Southern Asia have very, very high concentrations of mercury. And the first thing you do in an oil processor is start heating that oil to fractionate the different compounds, and with that you get huge mercury emissions with oil refineries. Since we're talking here, most of you, I assume, are based in Mexico City. Volcanoes are can be a very large source of mercury. And so that's something that you in Mexico City have to think about when you're thinking about mercury. Natural sources are thought to be about a third of the emissions going into the atmosphere. So it's very large sources. How much mercury per volcano depends on which volcano it is. I don't know much about the venting of mercury from the volcanoes in Mexico, but you do have them. So it's another source you have to worry about. And the other one that I point out is there is a lot of mercury coming off of forest fires. And so that's something you always have to contend with. Certainly we do here in the US and in Canada and in Siberia. So there's lots of sources around, lots of different kinds. So there's a lot of ways to move mercury into the atmosphere. Here's an emissions model from about 8 years ago or so. The largest emissions of mercury into the atmosphere in the world are coming out of Southeast Asia, China, India, Vietnam, Indonesia. These are all associated with manufacturing and coal combustion. In Indonesia, a huge amount of those are gold manufacturing and oil refining, because all of the basins in this area have very high concentrations of mercury. A lot of mercury emissions in Africa thought to be associated with gold production. In the US and in Asia and in Mexico, the mercury emissions are relatively small. Down here in South America, which is something Mexico needs to be concerned with, that is all primarily associated with coal combustion and gold production. Let's see. If you look at this and compare North America to the world, we're a fairly small component of mercury going into the atmosphere. Asia is the big one, 65%. So more than half is coming out of Asia, about 8% from North America. And here is a very poor, I apologize, close-up of Mexico, and wide-ranging emissions from the north to the south, primarily in the west, but a significant source of mercury. If this box represents the entire emissions of mercury into the atmosphere, you can see the big player is obviously China and India here, and I've highlighted the contribution from Mexico. Mexico is that box right next to the United States. So roughly, Mexico emits about half of what the US does. It's thought to be about 23,000 kilograms. And compare that to the entire emission to the atmosphere of about 20 metric tons. So Mexico is fairly small emission source, but it doesn't mean there's small deposition occurring. That does not necessarily follow. And then there's the chart of sources again. Coal combustion, this is gold mining, non-ferrous metal production, there's cement production, some of the more popular or important sources of mercury. There's small scale gold mining again. Again, I don't know how much of this is going on in Mexico, but down in South Mexico, I would bet quite a bit, because there's a huge amount of it going on in South America. There's my slide about forest fires again. There haven't been a whole lot of papers recently about this topic, but several big papers came out in 2008, 2009, that range, estimating that mercury emissions to the atmosphere from forest fires were on the order of about 30% of the total US annual emission. And I don't know personally a lot about forest fires, but forest fires are a huge source, and particularly in places like Canada and in Siberia area, Russia, and Western China. Out in those regions, since there aren't many people, when they have a forest fire, they tend to just let them burn. And so that's a continual source of quasi-natural mercury emissions to the atmosphere. So there's a lot of sources out there. Mercury gets in the atmosphere so a lot of different ways. So we know there's lots of sources of mercury to the atmosphere. We know it causes problems in humans, particularly children, and in animals eating contaminated foodstuffs. We know it's a problem from a health standpoint and what sort of problems it generates. And I would also mention that many of those same neurological problems could happen in animals too, with high concentrations of mercury. But then that brings us to so we know it's a problem. Now, what do we do now? Mercury is a global pollutant. It's an element. You can't get rid of it. What do we do? Well, the one thing that we figured out we could do is at least measure the rate of mercury flux down into the ecosystems. At where in the world is concentrations of mercury moving out of the atmosphere into the biosphere? Where are the important sections of that? And that's where my organization comes in, the National Atmospheric Deposition Program. We measure the flux of pollutants from the atmosphere down to the biosphere. That's what we do for a living. Just real quickly, we're a cooperative research project based at the University of Wisconsin. We spend about $3.5 million per year measuring this movement of pollution from the atmosphere to the biosphere. The U.S. Department of Agriculture calls this a National Research Support Project, meaning we make measurements that researchers use to do science. We measure the wet deposition of pollutants, or again, the flux of pollution out of the atmosphere into the biosphere. We also measure gaseous concentrations so we can estimate the dry deposition of mercury, in this case, down into the biosphere. We make these measurements at about 350 locations across North America. We also have measuring stations in Hawaii, the Virgin Islands, and Puerto Rico. And we also have a mercury site in Asia, and we're starting a new site in Bermuda. All of our data is made available to anyone that wants to use it. And historically, we have about 600,000 precipitation samples where we have identified the pollution and concentration in those precipitation samples. And we started all of these measurements in 1978, before I was even in college. And we're in our 44th year of operation. We have a lot of cooperators in the U.S. At the center of all this is the USDA, the regional state departments of agriculture here in the U.S. We have a federal government and state governments. The federal government is the driver, and all the states' agricultural resources have joined with us in this project, including many federal agencies. Some of these you will know. We have a lot of states that do monitoring within our network. Probably about 30 of the 50 are official members of NADP. We work with a lot of Native American tribal organizations. You may or may not know, but the tribal organizations are considered nations unto themselves, and they have their own environmental measuring capabilities, and we work with about 20 of those tribes. We have a lot of researchers at universities, much like yourselves, that run sites and make measurements, and then other organizations, including Environment Canada, EPA of Taiwan, British Petroleum was part of our organization at one point in time. Southern Companies, which is an electrical generator, was a member at one point in time. This is just a quick map of where we do our measurements, basically everywhere across the US. Most of our sites are in the east, where more of the people are. When you move out west, our sites get fewer, but we have pretty darn good coverage across the US. We have measurements in Alaska, Puerto Rico, and Virgin Islands. The US NADP is actually 5 separate networks. We have the National Trends Network, which most people know or think is NADP, where we measure basic pH of precipitation and cations, anions, and other fairly straightforward pollutants, where we do weekly measurements. But we also have the Mercury Deposition Network, where we measure wet deposition of mercury on a week-to-week basis. And we have the Atmospheric Mercury Network, where we make gaseous measurements of mercury to estimate dry deposition. We also have a fairly small litterfall network, which I'm not really going to talk about today. I'm going to focus on just those 2 networks, the wet deposition network and the gaseous network. These are our mercury measurement locations. It's a somewhat dated map, but basically we're measuring gaseous mercury in the east at the red stars, and we're measuring wet deposition at the green dots. For the wet deposition measurements, we have fairly good good spatial coverage of the US. Our atmospheric mercury measurements are very expensive to make, and they tend to be in the east. With these 2 networks, for the wet deposition, Mercury Deposition Network, where we're measuring mercury in precipitation, we do a week-to-week sampling. So we collect all the precipitation in 1 week and amalgamate that into one sample. That sample goes to the laboratory, and we look to see what the concentration of mercury is in that precipitation. In the Atmospheric Mercury Network, where we're measuring gaseous mercury in the atmosphere, we're measuring gaseous elemental mercury. So 3 different forms. We're measuring gaseous oxidized mercury, which is mercury salts, mercury chloride, mercury bromide, etc., and mercury associated with the particles in the atmosphere. These measurements are being made on an hour-to-hour basis with something called the TechGrand system, and here's a picture of that instrument. The problem with the TechGrand system is it's very expensive, and so that relates to not having that many sites. This is basically how mercury deposition works. You have a source emissions into the atmosphere. Mercury goes in the atmosphere in the elemental form or the reactive gaseous mercury form with a chemical valence of +2 or mercury salts, and then mercury associated with particulates. Those can be incorporated into a cloud and come down with rain droplets, or be underneath the rain as the rain washes it out, and we just capture that in a sample here. The mercury emission as elemental is not water soluble and does not come out in a wet deposition sample, but it can go through the atmosphere where it has a very long residence time. And if it's oxidized into one of these other 2 forms, it can come out and be found in our wet deposition sampler. On the gaseous side, this is the most important thing to be measuring: elemental mercury in the atmosphere. Here's a quick snapshot of the levels of mercury wet deposition across the US. We're talking on the order of our highest deposition is around the Gulf of Mexico, which would imply I would expect the same sorts of things on the Gulf side of Mexico. Deposition rates on the order of 20 micrograms, so 20 millionths of a gram per square meter per year. In the Northeast, it's more like 4 or 5. In the West, it tends to be very low, but be extremely high deposition up in the mountains. So this is the spine of the Rockies running right down there. And I would expect the same sort of results in Mexico, that you'd have high deposition at high elevations. You'd have high deposition of mercury along the Gulf Coast, and probably in and around Mexico City, because there are so many likely sources. If you look at our gaseous measurements, this is sort of a quick and dirty. On average, over the entire year for elemental mercury, this is the symbols here in gray or silver, our average concentration tends to be about just under 1.5 nanograms per cubic meter, so billionths of a gram per cubic meter. We tend to see that at almost all of our sites, but some of our sites in Alabama, which has a history of a lot of coal production, tends to be very high, and believe it or not, in Salt Lake City. Which is, again, another indication that I would expect higher than average concentrations in Mexico City of elemental mercury in the atmosphere. Not necessarily going to talk about GOM and PBM, those concentrations. These are picograms per cubic meter, and they tend to be highly variable and very site-specific. But overall in the US, for elemental mercury, we tend to find about 1.5 micrograms per cubic meter, except in special cases. Going a little long here, so I'm going to skip right over that. Why do we measure gaseous concentrations of mercury? So we can then take that and estimate dry deposition. To measure dry deposition directly is very difficult. The easiest way to estimate dry deposition is to take the gaseous concentration on average over a week, a month, a year, and then calculate using a model the deposition velocity, how quickly that gaseous mercury moves from the atmosphere down to the surface. And that's how we then estimate dry deposition of mercury, the average concentration in the atmosphere times the rate at which those molecules deposit down to the surface. And with that, in the next 6 months or so, we are going to start estimating dry deposition at every AMNet site that we have for every measurement on a week-to-week basis. So we can then say wet deposition from our wet network plus dry deposition from our model and measurements in our gaseous network will equal, quote unquote, total deposition of mercury in all forms through all manners. And that's going to happen on a regular basis with all of our sites and all of our measurements. This is done through a model. Given that I don't have a whole lot of time, here is 4 specific sites in the US. That's Ohio 02, New York 06. And you can see our estimates of dry deposition for each year for an annual number in dark blue versus our wet deposition at that site for that individual year. And you can see there are certain trends in there. I don't know if they will hold long term, but with this model mercury fusion in the US, we will be able to estimate and measure total deposition of mercury to any lake or any water body where we have monitoring near it. And so that's the goal of NADP, to be able to do that. Why do we spend all this money to do these kinds of things in the US? So you can track changes over time and space. Is mercury deposition getting better? Is it getting worse? Are the policies that we put in place to restrict the emission of mercury into the atmosphere working, or are they not working? Are we having any change at all? We can determine the extent of mercury problem, where is high deposition, where is low deposition, and we can track the implementation of the UN Mercury protocols, which is the global agreement with the UN between 140 countries to reduce the amount of mercury put into the atmosphere. That's why we spend the money to do these measurements. So with my final piece and my final 8 minutes, I want to talk about some ideas that Rodolfo and several other scientists in Mexico have been talking about in planning for just a while. We are planning to make, or to begin to make, Tech-Ran gaseous measurements of mercury, gaseous elemental mercury in Mexico City, basically to establish 1, 2, or 3 AMNET sites in and around Mexico City. We know we're going to do at least 2 with Dr. Sosa and his team, and we've begun to talk about a 3rd location with Dr. Rocio Garcia, north of Mexico City somewhere, making hourly measurements of gaseous elemental mercury and using the Tech-Ran system, as you see here. And here's a picture of Dr. Sosa's monitoring station up on the roof of the building that we would have all been in had we been live for this talk. What this instrument will provide is hourly estimates of gaseous elemental monitoring. And these are concentrations from my site in nanograms per cubic meter. And those measurements will go through a QA procedure and define if they're valid or invalid. And then we will do that for every hour of every year as long as the site is running. And that is quite valuable data to any of the researchers that do Mexico monitoring for air pollution. Here are the 2020 averages of elemental mercury in the US at our different sites that completed certain QA or meta QA standard. What you'll be able to do with this kind of measurement is determine the mercury concentration that is occurring in Mexico City, and then be able to compare it to all the sites in the US where the same measurements being made, or all the sites in Canada where the same measurements are made, or for that matter, the modeled concentrations of elemental mercury across the globe. If you'll look at this map, this is surface air concentrations of elemental mercury, just in a different nomenclature. You can see the this is actually the trend in those concentrations, with blue decreasing and red increasing. But if you look into the map, you'll see the small dots. That's the few places where they're actually measuring elemental mercury across the globe. And there are not that many of them. And so the question that we will be able to determine into the future is, where does mercury fit into this? Where does Mexico fit into this? If we can make measurements in Mexico City, the question will be, how high are they? Are they extremely high? Are they very low? There have been a few measurements made in the past in and around Mexico City by Dr. Garcia and Dr. Sosa, but long-term measurements would be quite valuable for the Mexican people and for the globe as we look to reduce mercury pollution for all. This data will be freely available to everybody that wants to use it. You'll be able to find it at our website associated with this network. What can you do with these measurements? Well, you can model dry deposition with them. You can do back trajectories to determine where those mercury concentrations are coming from. Where is all that mercury being emitted? Is it a local source? Is it a global source? You can do long-term trends, whether the concentrations of mercury and therefore deposition of mercury are getting better or getting more or getting worse in Mexico City. This is just a projection of some of you may have used back trajectory models in the past. They are very powerful. And here's a few examples of, not mercury necessarily, but examples of conditions of where the atmosphere was before it got to Mexico City. You'll be able to do that with any hour with valuable, varied data to determine what sources, what regions, where is all that mercury coming from. You'll be able to do concentrations in the city versus the industrial areas or outside the city area. Maybe Mexico will want to add wet deposition in the future. We can certainly always do that, but we're at least going to get this original AMNET site started in Mexico City, likely to be 3 in the near future. And that will also allow the country of Mexico to more readily conform with the calls from the Minamata and the UN, the Minamata Convention, to do more measurements of mercury around the globe so they can determine if the models they're using are correct or not. Quick summary of what I've told you this morning. In 2010, the average concentration of mercury in the atmosphere in the US was about 1.55 micrograms per cubic meter. Now it's gone down. So now, being 2022, it's gone down to about 1.35, which means deposition has also gone down. And we've seen these slow decreases across America and across Canada. And we've seen trends going down in wet deposition too. We know that mercury tends to be certainly higher in the cities. We've got lots of examples of that. Here is New Jersey 54, our site outside of New York City. They've shown it in Utah. They've shown it around the world. But the question then becomes, what sort of concentrations would you expect for Mexico City? And honestly, I don't know, but if I had to guess, I would expect higher than average, because you've got a lot of potential sources of mercury in and around Mexico City. You're sitting down in a basement with not a whole lot of ventilation, so I'd expect local mercury sources to build up their concentration. And you have one of these, which could be the largest source of all. And so I would tend to expect that the concentration of mercury in Mexico City would be rather high. But we need more measurements, and we're at least working to get those basic measurements started. And with that, I will hopefully end right on time and open up the floor for questions if anyone has them.
Thank you very much, David, for your excellent presentations. Now we are going to start with the session of question and answers. Le voy a pedir por favor a todo el público asistente, vamos a hacer las preguntas de esta manera. Si gustan, pueden levantar la mano y les voy dando la palabra. Las pueden hacer directamente en inglés para David. Si prefieren, otra forma sería a través del chat. La escriben ya sea en inglés o español y a su vez yo se la voy retransmitiendo a David. Y también tanto Marilu como Vivón están al pendiente en las redes y me están enviando la información de las preguntas que pueden hacer ahí. Pues vamos a dar inicio a la sesión de preguntas y respuestas y voy viendo quiénes están solicitando la palabra.
Hopefully you encourage them to ask them in English because my Spanish is terrible.
You need to travel to Mexico several times, David.
I need to go practice my Spanish. Yes.
Okay. Of course.
I'm ready.
And analyze Mercury. Okay. Now we are going to start with Michelle, please. Michelle Gruter, go ahead, please.
Yes, thank you for your presentation. Very nice, very interesting. What would you think would be a good proxy for other pollutants to correlate with mercury deposition? If you would have other pollutants available like gas phase or heavy metals?
Yeah, it's a very interesting question. And 20 years ago, when I got into this business, everybody assumed that sulfur dioxide and mercury should correlate very well because the major source at the time being coal, that's the major source of SO2. And I don't think they necessarily found that that was the case. And so I don't know off the top of my head if I can even answer that question. Mercury stays in the atmosphere, or elemental mercury, I should say, can stay in the atmosphere anywhere from 6 months to 2 years before it converts over to the oxidized form and comes out. Elemental mercury can deposit, but tends to, when the sun comes back out, it tends to evaporate back off. And so the mercury that you're measuring could have come from any source anywhere on the planet. And I don't know if it necessarily correlates well to anything that we traditionally measure. Sulfur dioxide, NOx, ozone. It does tend to be very stable though. There's not a lot of variability in the concentration, which implies, again, a global source, but I don't know what the answer to your question is, honestly. I don't think it correlates well with anything as a general rule. So,
okay, thank you very much.
Thank you very much, Michelle, for your question. Now, Doctora Rocío García. Go ahead, Rocío, please.
Thank you, Rodolfo. Hi, Dr. Guy. Thank
Rocío.
you. Congratulations. Hi,
good to
how
talk
are
to you. I'm great, thank you.
Okay, me too. Thank you. Congratulations on your presentation. Excellent. My question is, do you consider that mercury emission have an impact on climate change?
Can you say that one more time? Did you say, is there correlation to climate change?
Yes, the mercury emission.
Yeah, it is certainly related to climate change from the standpoint of, in the US, the issue of climate change is driving the government to try to encourage people to move away from coal. And so it is related to climate change in the fact that we are switching a lot of our power production from coal-fired to gas-fired. So it's related in that way. We're being pushed from a high mercury coal to, or a high mercury fuel source to a low mercury fuel source. It's related in that way. It's also related to climate change in this, from the standpoint that most models, at least that I've read, have said that in the future, we're going to need more electrical power, which is what dominates our cooling here in the US. And so it's relating in that way. I don't know that Mercury is considered an important absorber of radiation, so I don't think it's related to climate change in that way, but it is definitely related to how we respond to climate change. Needing more power, switching fuels, and all of that sort of thing. So it is related in that way.
Yeah. Very important to consider the climate change for the mercury emission, no?
Right.
Thank you.
Coal combustion in the US has been cut in half in the last, probably 6 or 7 years. That is not the case in Asia. They are burning more coal every year still. So.
Thank you,
Okay,
David.
Thank you, Rocio, for your question. Now, Pablo Sanchez, please.
Dr. David Guy, thank you very much for your presentation. I have a question.
Please.
What is the reliability of low-cost sensor with respect to the certified analyzer for mercury?
Say that one more time, Pablo.
What is the reliability of low-cost sensor with respect of the certified analyzer for mercury?
So what is how does the analyzer work? Is
Yes.
that basically
Yes,
the question?
regarding David, the low-cost sensors.
Oh, low-cost sensors.
Low-cost sensors for mercury.
Gotcha.
And compare it with the analyzer like the CRAN.
Right.
Of course, the cost, but what do you think about?
Yeah. There are very good passive samplers available now. So let me start with the Techran. And I took this slide out yesterday because I had too many slides. The Techran uses gold to trap or form an amalgam with the mercury that flows over the gold. And it concentrates the mercury and then heats it and drops it onto a cold vapor atomic fluorescence spectroscopy. That's how the Techran works. It's very expensive. A full speciating system, all the bells and whistles, is about $120,000 US per analyzer. Now, in the past 5 years, the Canadians and the Italians are working on one, and there's another one that they're working on in Asia, but the Canadian one has really shown very good scientific quality assurance at measuring elemental mercury. It uses a passive sampler, very inexpensive, no power required, and it uses it uses carbon-based collector to measure elemental mercury. The carbon attracts the mercury and it sticks to the carbon. Essentially, you take the carbon back to the laboratory, combust the carbon, trap it on a gold trap, and then introduce it to a cold vapor analyzer. Those are on the order of probably, I'm going to say like $50 or $60 per application or sampling period. And they can easily do a monthly sample. In in higher concentrations, they could probably do a pretty good job at a 2-week. And even in a higher concentration, maybe in a city with known higher concentrations, you could probably do a week-to-week sample with that passive for about $100 if you have the ability in your lab to do the detection. And NADP is about to start testing that passive sampler right next to our Techrans to be able to show scientifically that over a month's time, it's getting the average concentration as opposed to measurements being made by the Techrans. So I would say we're right on the verge of having a passive that everyone agrees works very well. It's also being tested by the Canadians. It's also being tested in part by the UN. And the hope is that we would have a global passive monitor that everyone can use. That's very inexpensive and requires no electricity. You can put it anywhere you want. So the future is bright, Pablo.
Thank you very much, Doctor.
Está apagado tu micrófono.
See, now, thank you, Pablo, for your question. Now, Dr. David Adams, please go ahead with your question.
Okay, can you hear me okay?
Yes.
Of course.
Okay.
Yeah.
Yeah, hi, Dr. Gay. Very interesting talk. I know absolutely nothing about mercury deposition or anything. I did have a question though, just in general, that might be a little bit out of your range.
Yeah.
What about all, for example, like these huge agricultural areas, thinking like, for example, the Imperial Valley or the Central Valley of California, or some areas of Arizona, or even certain regions in Mexico? How about mercury deposition in the soils and then absorption, so to speak, into the vegetables that we eat, or exposure, thinking about the people who actually work in those fields and things like that? Has anybody looked at something like that?
They've begun to look at like concentrations in row crops and field crops. What little I know about that topic is with corn, and since corn has such a high leaf area index, it tends to trap a lot of mercury that's moving in the atmosphere as it moves through. And so there is a little bit of work out there about mercury in foodstuffs, not a whole lot, at least that I'm aware of. Now, mercury in soils, though, is a well-studied topic area. There is a huge amount of mercury in the soil. The idea is that mercury is an element, so it doesn't go anywhere. It just changes its form, and maybe it moves itself around because it's volatile in many of its states. And there's a lot of mercury in a lot of places, and the highest concentrations of mercury in soils tends to be in the western US, in the drier part, where all of our historic gold and silver mining was done. So I'm thinking Nevada, Utah, California, where they used a lot of mercury to capture all that gold, where they were basically forming a gold amalgam with mercury in the river. They have a huge problem in all the rivers that feed down into San Francisco from all the mining, I'll call it waste of mercury that's around. But getting back to your questions about the soils, a lot of contaminated mercury from previous uses is still blowing around, and a lot of that mercury can collect in soils. And so if that's your area of interest, is that mercury in soils moving into the food stuff, the row crops, the grains, etc., there's probably a lot of work that needs to be done for sure. And I know every grasslands, so all the grains, as they're growing, they probably pick up mercury, because many of the forms of mercury in the atmosphere are very sticky from an electrical perspective. And as the mercury flows through, any leaf area at all is going to pick up a lot of mercury. So if if they're burning crops, they're emitting a lot of mercury. When they heat up the soil with any kind of fire, there's huge emissions of mercury. So there's definitely a lot of mercury in the soils, without question.
Okay. Yeah, no, that was just kind of a curiosity. I don't know. I pass through these regions a lot. I work a lot in southwestern California and northwestern Mexico, and that more just from visual. And I think I've heard in the past about this idea of particularly like in the Imperial Valley.
Sure.
It's hard to see. There could be like high amounts of mercury in the soils. But thanks. I appreciate the answer. It's a nice talk.
Oh, sure. You probably passed all that rice growing region that they do up in like around Sacramento.
Right.
And there you've got warm temperatures and anoxic water conditions. And so rice production, at least, has been theorized to be a huge source of mercury back to the atmosphere because of all the mercury falling into it through wet deposition.
Okay. Bueno, gracias, Rodolfo. Thank you again.
Thanks, David, for your question to David. Okay, I am going to raise some questions from the chat and get back to the Zoom platform. I have this is a comment from Juan Carlos Ramirez from Marietta College, Ohio. Juan Carlos is working at the Technical Committee of Air and Waste Management Association. Best regards and congratulations. Jose Hernandez from Veracruz Port, best regards. Rocio, hi David. Pablo, he has already made their question. John Walker, very nice seminar, Dr. Guy. Thank you. Monica Solano, thank you for your talk. In your opinion, would there be a reduction in mercury levels if diesel and oil vehicles were changed for hybrid or electric vehicles? Electric and hybrid vehicles use batteries, which also contribute for mercury emissions.
Sure. So from the standpoint of would you reduce mercury coming out of the tailpipes? Certainly you would, because they'd go to zero emissions, but there's not a lot of mercury in gasoline and diesel. There is some, but there's not a lot. But then again, the flip side of that would be if you had an entire vehicle fleet, as we term it in the US, of electrical vehicles, then you'd need a lot more electricity to power those vehicles. And then the question would become, how do you generate the electricity? If you're generating with coal and you're not able to control the mercury emissions very well, then you could potentially actually add mercury to the atmosphere by converting to electrical vehicles. It would all depend on how you generated the power and how good you were at taking it out. And certainly making batteries is a nasty business. There's all kinds of elements in batteries. Off the top of my head, I don't know if there's any mercury contamination in batteries, but I've been told by a USGS coal expert that he said it doesn't matter. If it's in the ground, it's got mercury in it. So I'm willing to bet that if you looked hard enough inside a battery, you'd probably find plenty of mercury contamination in those batteries too. And so all that mercury gets generated when you start forming lots of batteries. So I would be willing to bet it's a significant source, at least to look into.
Okay, thanks Monica for your question. Thanks David for your answer. Now Mayra Cuellar, thank you. Would you think that Mexico should have an alert for the population in this matter zone? I know there isn't any right now. Would is already too late?
Say that one more time, Rodolfo. What's that question again?
This is a very general question. This is, would you think that Mexico should have an alert for the population in this matter zone regarding to mercury? Thinking in that population information.
There's mercury everywhere. There's lots of mercury emission with people. So I would expect higher concentrations in mercury cities, just like in the US for sure. If you were worried for more focused on mercury concentrations in people, where would I look for problems? I would look for subpopulations that eat a lot of fish. So I would look at poor people living along the coast that are subsistence fishing. Those are most likely to be the populations with the highest concentration of blood mercury. Did that answer the question?
Okay. This is a comment. Thank you so much, Dr. Gay. This was an excellent talk from Lourdes Pineda. I have another question for Dr. Violeta Mujica from Metropolitan University. Nice presentation. Congratulations. Which public policy has been the most successful as a result of mercury monitoring? Of course, in USA.
So what restriction has been the most to reduce mercury?
Strategies, control strategies, and the resulting in a better quality for mercury.
Yep. Up in the from 2010 on, coal-fired power plants were required in the US to begin to monitor their emission rates and to add engineering controls to control for mercury emission, to reduce mercury emission. that one thing has reduced the US contribution in a huge way recently. But before that, one of the big sources was industrial uses of mercury in making all sorts of things. And basically all of that has gone away in the US. Chlor-alkali facilities come to mind where they were actually using mercury in the production. Excuse me, very little of that occurs anymore in the US and globally for that matter. And that has a huge reduction in the mercury emissions. And the other big one that I always say is when you're talking about small scale gold mining, basically what they do is they take the ore that they think has gold and silver in it. They mix liquid mercury in it to form the amalgam, just like we have in, or like us older people have in our teeth. And to make the gold and silver settle out, they take that back to a retort facility where they basically boil it and boil away the mercury. And probably the smartest thing that UN has done on a global scale is to encourage people and teach them how to use retort facilities where they can actually capture that mercury leaving from the gold amalgam heating process and recycle it, cool it back down, and convert it back into mercury so they can reuse the mercury. Those three things are some of the major things that have been done over the past 30 years to restrict mercury going into the atmosphere. And the other one that I'll mention is the US is going through a huge conversion from coal combustion to natural gas production. And the natural gas levels are very low. And so those four things have had a huge effect on the mercury emission from the US. And the same would be true for any country, Mexico or Indonesia or China.
Okay, I have more questions. Comments or questions from Dr. Alejandro Murad from Universidad Distrital de Colombia. It's very interesting to mention that we had an attendance from the United States, from Spain, from Colombia, and from different states in Mexico.
That's good.
Dr. Alejandro said about excellent presentation. In the measurements of air quality, how important is the measurements of mercury in cities or reservoirs that may be far from emission sources? Does its dispersion occur in the long term as well as its permanence?
Yep.
This is regarding the dispersion of mercury, David. Okay?
Yep. We see mercury contamination everywhere across the US and everywhere across the globe, whether it's close to sources or not. We tend to have higher concentrations in the cities, therefore higher depositions in the cities. But again, the mercury issue is not necessarily one of breathing mercury gas, although that can be an issue in like industrial settings or near big sources. But in general, it's biomagnification of mercury in the organic form up the food chain. And so the biggest contamination locations tends to be where people eat a lot of fish. If you eat fish and consume mercury faster than you can eliminate it from your body, then your concentration goes up. And if you're a female and of reproductive age or small children, that's where you create the problems. So typically where we see the highest concentration are in people that eat, in populations that eat a lot of fish. And the classic example of this is Japan, Korea, coastal China, and all the island nations in Southeast Asia. They eat a huge amount of fish, and they have very high concentrations in the atmosphere. So a lot of mercury going into the system. And that's where we see the biggest problem of mercury in people. The highest concentrations you'll find in the atmosphere where there are a lot of sources. So sources of atmospheric gold mining, and South America comes to mind there, or where they burn a lot of coal. Industrial cities, cities where they burn coal without restriction of the air quality. That's where you're going to find the highest concentrations in the atmosphere.
Okay, I had a comment and best regards from Ann Hansen that you know her very
hello,
well. Okay.
I do. Good to
Okay,
hear from
thank
you,
you. Thank you very much for the presentation, David. Ann Hansen, she's working at the Mexican Institute for Water Technology.
Great to hear from you, Ann.
Cuernavaca, Mexico, okay? And now from Lily Alonso, she's working at the University of Baja California, Sud Baja in Mexico. Thanks so much, doctor, for your presentation. How would you start measuring mercury in a city where there is not as much support or interest from the government?
Yeah, I mean, if you had equipment, which a lot of people don't because it's so expensive, we do it like we're going to do it in Mexico. We'd establish a few sites and see what we find. You know, if you don't have $120,000 laying around, or you don't have an instrument, probably the next best way to do it would be to use passive in the atmosphere, and with that same instrument that you could use to do the passive measurements in your laboratory, which is probably on the order of maybe $30,000. You could do fish concentrations, you could do soil concentrations, you could do a lot of different kinds of applications with the same analytical instrument. And so that's probably how I would recommend it get done.
Okay, thank you, David. This is the last question because the time is over. Yep. Dr. Carlos Guy from this institute. Carlos, yes. Please go ahead with your question.
Thank you. Thank you, Dr. Guy, for your presentation. Very interesting. Can you give us an estimate of what would be natural sources of mercury and the proportion of artificial mercury, and what would be the expectations of eliminating the latter from industrial processes?
Well, so when you think about mercury moving in the atmosphere and the sources involved, the source groups, you can divide them. About a third of the emission in the atmosphere is from natural sources, about a third from industrial sources, and then about a third of mercury that got emitted by one of those two sources years ago resided in the soil for a while and then went back into the atmosphere. So industrial sources and natural sources are thought to be about the same size. The natural sources that are important, volcanoes, that's the first one. The second one would be forest fires, if you consider that a natural source. But a forest basically gets coated by all the mercury in the atmosphere. The mercury flowing through the forest sort of gets draped on all of the leaves and twigs. Forest fire comes through, all that mercury gets revolatilized. So that's, if you want to consider that a natural source, it's actually a mixed source. That's the second one. And you can't stop volcanoes. With forest fires, about all you can do is stop. You put them out or you stop them from getting started to begin with. But then when you move down further into other natural sources, a lot of mercury volatilizing out of the oceans. I've forgotten the number, but I want to say it's like 70 million metric tons of mercury is thought to be floating around in the oceans. How do you stop that? I don't know. It's not a very concentrated source, but it's certainly a very wide-ranging source. And there's not much you can do about those. So from the natural source, there's not a whole lot you can do. Really about all we can do is try to trap mercury and sequester it. And the US does that. You can't really sell mercury anymore. Just out on the open market from the US, they've restricted those sources. And so that's really about the only thing you can do is try to trap it and store it away, because it's an element that just keeps moving around the planet and it's not going away. It just changes forms. So it's a pretty tough question, yes. But it's nice to talk to you. You must be my long lost cousin.
Yeah, or maybe your uncle.
Thanks, Dr. Guy, for your question. Thanks, Dr. Guy,
Yeah.
for answering the question. Now, I'm sorry for the people that continues asking. The time is over, but I'm going to be in touch by email with David or with me. There is no problem. This is only the point of a start for the collaboration. Thank you very much, David. Always is very nice to talk.
My pleasure.
And listen to you.
My pleasure.
We hope that the next presentation will be face-to-face.
You got a deal there.
Always are welcome to Mexico.
Yeah.
Thanks again.
You got a deal there. My pleasure.
Okay. And I would like to talk with Dr. Jorge Zavala. Jorge, you want to give some words to finish this event?
Well, I also want to say thank you very much. Muchísimas gracias, Dr. David Guy. It was
My
a
pleasure.
very interesting
Thank you.
talk.
Thank you.
And we have a lot of people that were following your talk in the 3 different options, and hope to see you soon here in Mexico.
I'll be there.
Thank you very much.
Thank you.
Muchas gracias a todos los que atendieron el seminario. Los invitamos a que sigan el seminario institucional de nuestro instituto. Muchas gracias. Hasta luego.